We are told that throwing things away is cheaper than fixing them. But the shoe repair shop on Main Street, the one that closed in 1997, proved that was a financial lie built on a cultural shift we never voted for. Look at the Resoling bench, not the flimsy particle board workstations you'd find in a modern cobbler's kiosk at the mall. This was 2 inches of solid maple, 48 inches wide, worn smooth by 60 years of leather dust and neat's foot oil. The surface had a permanent topography, shallow depressions where the same tools had rested in the same positions for decades. The vise bolted to the corner wasn't cast aluminum. It was forged steel, painted institutional green, capable of exerting 1,200 pounds of clamping force without flexing. When you turned the handle, you felt the Acme thread engage with mechanical certainty. No slop, no play. This bench weighed 300 pounds empty. It was not furniture. It was infrastructure. To the modern eye, this looks like a workbench in a dying trade. But to the forensic historian, this was the anchor point of a decentralized repair economy that kept 60 million pairs of shoes in circulation that would otherwise have entered landfills. The bench was not just a surface. It was the foundation of a system that treated manufactured goods as long-term assets rather than short-term consumables. And that system worked with mathematical precision until we were seduced into believing that replacement was progress. The shoe itself tells the first part of the story. A men's dress shoe manufactured between 1945 and 1975 was not designed like modern footwear. The upper was full-grain leather, not the corrected grain or bonded leather composite used today, but hide with the entire dermis structure intact. Thickness 5 to 7 ounces. That measurement refers to leather weight, where 1 ounce equals 1/64th of an inch. This material had tensile strength and tear resistance that increased with age as the fibers compressed and interlocked. The leather was vegetable tanned, a process requiring 6 to 8 weeks in tannin baths derived from oak bark or chestnut wood. This method produced leather that could absorb and release moisture, that would patina rather than crack, that could be reconditioned indefinitely with oils and waxes. The leather came from steer hides, not the split leather or suede that dominates today's market. A single hide yielded enough material for approximately 3 pairs of shoes, with the premium sections, the bend, the area along the spine, reserved for uppers where flexibility and strength were both required. The tannery would grade each hide, marking defects with chalk, cutting around scars and brand marks. What remained was leather dense enough that you could not easily push a thumbnail through it, yet supple enough to form around the last without cracking. But the genius was not in the upper. The genius was in the welt. Goodyear welt construction. That means the upper leather, the insole, and the welt, a narrow strip of leather that runs around the perimeter of the shoe, were stitched together in a single lock-stitch seam. The welt itself was typically 3/16ths of an inch wide and 1/4 inch thick, cut from shoulder leather chosen for its density and resistance to compression. The stitching used was not the lightweight thread you'd find in garment construction. This was linen thread, often waxed with beeswax, thick enough to be visible to the naked eye. The stitch count was 8 to 10 stitches per inch, coarse by modern standards, but intentionally so. Coarse stitching was stronger. It distributed stress across a wider area. It did not concentrate tension at any single point. The outsole was then stitched to the welt, not glued to the upper. This created a mechanical joint, not a chemical bond. The implications of this design were profound. Because the outsole attached to the welt rather than the upper, you could remove the outsole without destroying the structural integrity of the shoe. You could replace it. You could do this 10, 15, 20 times over the life of the shoe. The welt itself could be replaced if necessary. Every component was modular. Every component was serviceable. The shoe was not a sealed unit. It was an assembly, and assemblies can be maintained indefinitely. Consider the economics embedded in this design philosophy. A quality men's dress shoe in 1955 cost $38. The median weekly wage was $75. The shoe represented roughly half a week's income for the average worker. You did not treat such an item casually. You did not discard it at the first sign of wear. The manufacturer knew this. The manufacturer designed accordingly. The shoe was built with the assumption that it would be resoled multiple times, that it would see a decade or more of regular use, that it would be maintained rather than replaced. This was not planned obsolescence. This was planned permanence. The resoling process required 12 separate operations, each demanding specific knowledge and specialized tools. The cobbler started by removing the old outsole with a specialized knife, not a box cutter, but a curved leather blade with a handle worn to the shape of his palm. The blade had to be sharp enough to slice through aged leather and dried adhesive, but controlled enough not to cut into the welt stitching beneath. He worked the blade between the sole and the welt, cutting the stitches one by one, feeling for the resistance that indicated he was approaching the welt itself. This was not a task you could rush. A single, deep cut into the welt could compromise the entire structure. Once the sole was removed, he cleaned the welt surface with a wire brush, removing old adhesive and compressed dirt. The welt, after years of service, would be compressed, darkened with oils and street grime, the stitching holes slightly elongated from wear. He inspected each stitch hole. He inspected the welt itself for cracks, for separation from the insole, for any sign that the structural integrity had been compromised. If the welt stitching was intact, he moved forward. If it was compromised, he re-stitched the welt to the insole using a hand crank stitcher with waxed linen thread, not nylon, which would cut through the leather over time, but linen, which compressed and swelled with moisture, creating a self-sealing joint. The hand crank stitcher was itself a marvel of industrial design. A cast iron frame bolted to the bench, a curved needle thick as a roofing nail, a bobbin mechanism that created a lock stitch as the needle punched through the layers of leather. The cobbler worked the hand crank with his right hand while guiding the shoe with his left, feeling the resistance as the needle punched through the insole, through the canvas rib that reinforced the welt channel, through the welt itself. Each stitch had to be precisely placed in the existing holes. Deviation would weaken the structure. Next came the sole preparation. The replacement sole was pre-cut leather, typically 8 to 10 irons thick, that's 8 to 10 32seconds of an inch. The leather came from the back and shoulder of the hide, the densest part, where the fibers were most tightly compressed. The cobbler selected the sole based on the customer's needs. A businessman who walked primarily on pavement would receive a harder, denser sole. A farmer who walked on soft ground would receive a slightly softer sole with more flex. This was not standardization, this was calibration. He soaked the sole in water for 20 minutes to make it pliable, then shaped it using a heated metal form called a sole iron. The iron was essentially a shoe-shaped anvil heated to approximately 300 degrees Fahrenheit. He pressed the wet sole leather against the iron, using a wooden paddle to work the leather into the curve of the instep, the contour of the heel. As the leather heated and dried, it held the shape permanently. This was thermoplastic forming, but with organic material rather than petroleum polymers. He trimmed the sole to match the welt perimeter, using a circular leather knife mounted on a pedestal. The knife was a rotating wheel, razor sharp, that he guided along the welt edge while turning the shoe against the blade. The edge had to be precise. A gap of more than 1/32 of an inch would allow water infiltration and delamination. An overlap would create a ridge that would wear unevenly and create a tripping hazard. He applied contact cement to both the welt and the sole, not modern polyurethane adhesive, but neoprene-based cement that remained flexible and could be reactivated with heat for future repairs. The cement was applied with a brush in thin, even coats, allowed to dry until tacky. This typically required 15 minutes in a shop kept at 68 degrees. The cement created an initial bond, but the real strength came from the stitching. He pressed the sole onto the welt using a mechanical sole press, a cast iron device with a foot-operated lever that applied even pressure across the entire sole surface. The press looked like a small printing press, 2 flat steel plates, the bottom stationary, the top controlled by a lever arm with a mechanical advantage of approximately 10 to 1. He positioned the shoe between the plates and pressed down with his foot. The sole compressed against the welt, the cement bonded. He held the pressure for 30 seconds, then released. Then came the stitching. He used a Landis stitcher, an industrial sewing machine weighing 200 pounds, driven by a 1-horsepower electric motor capable of punching through half an inch of stacked leather with a needle the diameter of a finishing nail. The machine sat on a dedicated cast-iron table, bolted to the floor to manage the vibration. The stitch was a rapid lock stitch, 60 stitches per minute, with polyester-wrapped cotton thread strong enough to support the shoe's structural load, but organic enough to eventually biodegrade if the shoe was ever discarded. The cobbler guided the shoe through the machine, following the perimeter of the sole, keeping the needle precisely 1/4 inch from the edge. The needle punched down through the sole, through the welt, caught the bobbin thread beneath, pulled it up through the leather, and locked it in place. The sound was rhythmic, industrial, a rapid pneumatic punch punctuated by the whir of the motor. This was not quiet work. This was mechanical force applied to resistant material. After stitching, he trimmed the excess sole material with a sole edge trimmer, a rotary blade mounted on an adjustable arm. The blade beveled the edge at a 30-degree angle, creating a transition from the vertical sole edge to the horizontal welt surface. This bevel served both aesthetic and functional purposes. Aesthetically, it created a clean line. Functionally, it prevented the sharp 90-degree edge from catching on stairs or curbs and peeling the sole away from the welt. He sanded the edge smooth with progressively finer grits, 80, 120, 220, until the leather edge was burnished to a glassy finish. The coarse grit removed the saw marks from the trimmer. The medium grit smoothed the surface. The fine grit polished it. He worked the sandpaper in long strokes, following the curve of the sole, applying even pressure. The leather dust collected in the air, a fine brown mist that settled on every surface in the shop. Finally, he applied edge dressing, a wax-based compound that sealed the exposed leather fibers and gave the edge a polished appearance. The dressing came in brown, black, or neutral, matched to the color of the sole. He applied it with a small brush, working it into the edge, then buffed it with a cloth wheel mounted on a bench grinder. The wheel spun at 1,800 revolutions per minute. The friction generated heat. The heat melted the wax. The wax penetrated the leather and dried to a hard, glossy finish. The entire process took 45 minutes. The cost in 1975 was $12. Adjusted for inflation, that is $68 today. The shoe, after resoling, would last another 5 to 7 years of daily wear. Over the life of the shoe, a customer might resole it 4 to 6 times, paying $48 to $72 in total repair costs for a shoe that originally cost $40. The math appears counterintuitive until you realize that the alternative, replacing the shoe every 2 years at $40 per replacement, would cost $160 over the same 16-year lifespan. The repair was not an expense, it was an investment with a measurable return. But the resoling bench was just furniture. The real engine of the system was hidden in the financial architecture beneath it, the repair ledger. Most shoe repair shops did not operate on a cash-only basis. They used a ledger system nearly identical to the general store credit model. The cobbler kept a cloth-bound journal with each customer's name, the date of service, the type of repair, and the amount owed. The ledger was typically 8 inches by 12 inches, bound in black buckram, with hand-ruled columns. The entries were made in pencil, occasionally in ink, in handwriting that became progressively less legible as the cobbler aged and his hands stiffened with arthritis. Payment was not required at the time of service. You dropped off your shoes. The cobbler wrote your name in the ledger, noted the repair, quoted the price. You agreed. You left. A week later, you returned. The shoes were ready, sitting on a shelf behind the counter with a paper tag tied to the laces bearing your last name. You picked them up. You wore them out of the shop. Payment could happen immediately, or it could be deferred. The cobbler might say, "Pay me when you can," or "Catch me next time," or simply say nothing at all and turn back to his bench. The debt was recorded. The debt was known. But the debt was not enforced through legal mechanisms. It was enforced through social mechanisms. The cobbler knew where you lived. He knew where you worked. He knew your father. He knew your children. He saw you every Sunday at church, or every Thursday at the diner, or every Saturday at the hardware store. The debt was not anonymous. It was visible. And because it was visible, default was not a financial risk. It was a social risk. Consider the enforcement mechanism. The cobbler did not need a collection agency. He did not need to file a claim in small claims court. He did not need to send threatening letters or make phone calls. He needed only a memory and a position within the community's information network. If you stiffed him, everyone knew, not because he gossiped. That would have been unseemly, a violation of the professional discretion expected of tradesmen, but because your absence from his shop was conspicuous. In a town of 3,000 people, everyone knew who wore Resole shoes and who bought new ones. The choice was a signal. Resoling meant thrift, practicality, respect for craftsmanship. It meant you understood the value of maintaining what you owned. It meant you had a relationship with the cobbler, and by extension, with the network of tradesmen and merchants who formed the economic backbone of the town. New shoes every year meant either wealth or wastefulness, and in most communities, wastefulness was judged more harshly than poverty. A man who bought new shoes while owing the cobbler $12 was not seen as prosperous. He was seen as dishonorable. The ledger recorded more than debt. It recorded character. And because character was recorded, the system achieved a repayment rate that would astonish modern financial analysts. Default rates in small-town repair shops were typically below 3%. No credit scores, no background checks, no algorithms predicting your likelihood of repayment based on your zip code and purchase history. Just visibility and consequence proximity. Consequence proximity. That means the person you wronged was the person you would see tomorrow. The transaction was not anonymous. The relationship was not disposable. You could not ghost the cobbler. You could not leave a bad review and move on to the next vendor. There was no next vendor. There was only him. And if you burned that relationship, you walked on worn-out shoes, or you drove 30 miles to the next town where you had no reputation at all and would be required to pay cash up front. The system did not ask people to be honorable. It made honor economically rational. The ledger was a reputation tracking system more sophisticated than any blockchain, more accurate than any credit bureau, because it was local, immediate, and socially enforced. This is what modern behavioral economists miss when they analyze historical commerce. They see the ledger system as inefficient. They calculate the overhead cost of maintaining handwritten records, the risk of non-payment, the lack of scalability. They would call this a primitive credit system in need of modernization, but they would be measuring the wrong variables. The ledger was not designed to maximize transaction volume or minimize default risk through legal enforcement. It was designed to maintain relationships, and relationships in a small-town economy were the actual currency. Because the cobbler carried your debt, you could not be anonymous. Because you could not be anonymous, rudeness had consequences. Because rudeness had consequences, civility was not a virtue, it was a survival strategy. The system did not ask people to be kind, it made kindness rational. You did not say please and thank you because your mother taught you manners. You said please and thank you because the cobbler would remember if you didn't, and that memory would affect whether he extended you credit next time, whether he prioritized your repair over someone else's, whether he gave you the careful work or the adequate work. The repair economy extended beyond shoes, the same ledger system, the same community visibility, the same consequence proximity. Governed watch repair, appliance repair, furniture repair, textile mending, small engine repair, leather goods restoration. Every town of more than 1,500 people had a fix-it infrastructure, a cobbler, a watchmaker, a seamstress, a small engine mechanic, an upholsterer, a furniture refinisher. These were not luxury services. They were infrastructure. They existed because manufactured goods were expensive relative to labor, and because the goods themselves were designed to be repaired. A 1952 Kenmore washing machine was not a sealed appliance. The back panel was held on with 8 screws, not torque security screws or tri-wing fasteners designed to prevent user access, but standard slotted screws that any homeowner with a screwdriver could remove. Inside, every component was accessible: the motor, the pump, the timer, the transmission, the drive belt, the water inlet valve. Each component was modular. Each could be removed and replaced without disturbing the others. The service manual, included with the machine, not locked behind a manufacturer paywall or restricted to authorized service centers, contained exploded diagrams showing every part and its relationship to every other part. It contained torque specifications for bolts. It contained wiring diagrams. It contained troubleshooting flowcharts that walked you through systematic diagnosis. If the machine does not fill, check the water supply. If the water supply is adequate, check the inlet valve. If the inlet valve is functional, check the timer. The manual assumed you were intelligent enough to follow a logical process. Replacement parts were available from Sears for 20 years after the model was discontinued. Not just common wear items like belts and hoses, but structural components, motors, transmissions, pumps, timers, and the parts were not serialized or locked to specific machines. A motor from a 1952 model would fit a 1958 model. A timer from a 1955 model would work in a 1960 model. This was standardization in service of repairability, not in service of manufacturing efficiency. The machine was designed with the assumption that it would fail, and that a technician with basic tools could restore it to function. The economic logic was clear. A washing machine in 1952 cost $250. The median household income was $3,700. The machine represented 6.8% of annual income. You did not throw that away. You could not throw that away. So the machine was built to be maintained. The motor was a split-phase induction unit, overbuilt to the point of absurdity by modern standards, capable of running continuously for 72 hours without overheating, rated for 50,000 start cycles when the typical residential usage pattern required perhaps 1,500 start cycles per year. The motor would outlast the machine. The pump was bronze, not plastic, because bronze did not degrade in continuous contact with water and detergent. The transmission gears were hardened steel, cut with precision tolerances, running in an oil bath that needed to be changed every 5 years, a maintenance task detailed in the manual with photographs and step-by-step instructions. The timer was perhaps the most elegant component. It was a mechanical camshaft device with 23 discrete positions, each controlled by a spring-loaded detent. As the timer motor advanced the camshaft, metal cams would open and close electrical contacts in precise sequences, controlling the fill valve, the motor, the drain pump. The timer could be disassembled, cleaned, and reassembled by a competent technician in 90 minutes. The cams were steel. The contacts were silver-cadmium alloy, chosen for its resistance to arcing and oxidation. When a contact wore out, typically after 15 to 20 years, you did not replace the timer. You replaced the contact. The part cost 60 cents. And when the machine finally did fail, after 20, 25, 30 years, the failure was not catastrophic. It was predictable. The motor bearings wore out. The pump seals dried and cracked. The timer pawl broke. These were serviceable failures, failures that announced themselves with symptoms that could be diagnosed. A grinding noise meant bearings, a leak meant seals. A failure to advance meant the timer. The appliance repairman arrived with a canvas tool bag and a pocket full of common parts. He diagnosed the problem in 10 minutes. He ordered the specific part if he did not carry it in his truck. He returned a week later. He replaced the component. The machine was restored to function. The customer paid $30. The machine ran for another 10 years. This was not an economy of consumption. It was an economy of stewardship. And the stewardship was enforced not by environmental consciousness or moral virtue, but by economic necessity and social structure. You maintained your possessions because replacing them was expensive. You maintained your relationships with repairmen because you would need them again. The repairman maintained his reputation because his livelihood depended on repeated business from a limited customer base. And all of it, the repair infrastructure, the ledger system, the community visibility, the assumption of durability, was anchored to that maple Resoling bench. It was not a workbench. It was a stage where the covenant of repair was performed daily. You brought in your shoes worn but not destroyed. The leather was scuffed, the sole was thin, but the structure remained intact. The cobbler examined them with the clinical eye of a surgeon evaluating a patient. He assessed the damage. He determined what could be saved. He quoted you a price. You agreed. You left the shoes. You returned a week later. The shoes were restored, not to new condition, but to functional condition. The leather still bore the creases of your gait. The heel counter still held the shape of your ankle. But the sole was new. The structure was sound. The shoes would carry you for another 5 years. You paid or you promised to pay, and the promise was recorded in the ledger. The bench held the weight of the transaction, the weight of the relationship, the weight of a system that valued repair over replacement, that valued relationships over transactions, that valued memory over anonymity. Then came the Trojan horse, and it arrived not as an enemy, but as a miracle. Polyurethane, 1959. A polymer developed initially for industrial insulation by Otto Bayer in Germany in 1937, adapted for footwear by chemical engineers at DuPont and Bayer AG in the late 1950s. The material could be injection molded directly onto a fabric upper, creating a sole bonded at the molecular level to the shoe body. No stitching, no welt, no modularity. The chemical bond was created through a reaction between polyol and isocyanate, catalyzed by heat and pressure that formed long-chain polymers with extraordinary properties. The process was fast. A complete sole could be molded in 90 seconds compared to the 45 minutes required for traditional resoling. It was cheap. The raw material cost was approximately 1/8 that of leather. A pound of polyurethane resin cost 40 cents in 1965. A pound of sole leather cost $3.20, and the finished product had properties that leather could not match. It was waterproof, completely impervious to moisture. It was lightweight, roughly 60% the weight of leather. It provided cushioning through the cellular structure of the foam, a property leather could never achieve. The industry called it a revolution. And in many ways, it was. Polyurethane soles were lighter than leather. They required no break-in period. They did not absorb water. They did not crack or dry out. They provided shock absorption that made them preferable for athletic applications. A basketball player wearing leather-soled shoes in 1955 was essentially playing on hard wooden blocks. A basketball player wearing polyurethane-soled shoes in 1968 had cushioning that reduced impact stress on knees and ankles, and they were affordable. A pair of polyurethane-soled work boots cost $12 in 1965. A pair of Goodyear welted leather work boots cost $45. The consumer saw the price difference and made a rational choice based on the information available. Why pay $45 for boots that would need resoling every 3 years at $12 per Resole when you could pay $12 for boots that would last 2 years and then be replaced? The math seemed obvious. But the math was incomplete. The calculation was based on a false equivalence, that the polyurethane boot would provide the same service life as the leather boot. It did not. The polyurethane sole could not be resoled. The bond between the sole and the upper was permanent, not mechanically permanent like a weld, but chemically permanent like vulcanized rubber. The molecules of the polyurethane had interpenetrated the fabric of the upper during the molding process. When the sole wore out, the shoe was finished. You could not separate the components without destroying both. You could not replace the sole without destroying the upper. The shoe had become a sealed unit, an appliance, a disposable. The cobbler could do nothing. He could replace a heel, perhaps, if the shoe had a stacked polyurethane heel that could be pried off and replaced with a conventional leather heel. But the sole itself was untouchable. There was no welt to stitch to. There was no mechanical joint to disassemble. The sole was bonded. And because the sole was bonded, the customer stopped visiting the cobbler. The resoling bench sat unused. The Landis stitcher fell silent. The ledger was no longer updated. The relationship dissolved. The promise had been convenience and affordability. The trade-off was permanence and repairability. We gained lighter shoes. We gained waterproof shoes. We gained cheaper shoes. We lost the ability to maintain them. We lost the relationship with the craftsmen who maintained them. We lost the visible credit system that the relationship enabled. We lost the community enforcement mechanism that made the credit system functional. The shift happened gradually, then suddenly. In 1960, 82% of American shoes were Goodyear welted or similar repairable construction. By 1970, that figure had dropped to 51%. By 1975, it was 31%. By 1985, it was 9%. By 1995, it was less than 3%, and most of that 3% was high-end dress shoes selling for more than $300, luxury items, not everyday footwear. The cobbler shops closed in waves. First, the small-town locations, where customer volume could not sustain a business built on repairs that no longer happened. A cobbler in a town of 4,000 people might have serviced 300 regular customers in 1960, with each customer bringing in shoes for resoling twice per year. 600 transactions annually at $12 per transaction generated $7,200 in revenue. Subtract overhead, rent, utilities, materials, insurance, and the cobbler might net $3,500, roughly equivalent to the median income. But by 1975, half his customers were wearing polyurethane-soled shoes. His transaction volume dropped to 300 annually. His revenue dropped to $3,600. His overhead remained constant. His net income dropped below the poverty line. He could not sustain the business. He closed the shoe shop. He sold the equipment at auction. He took a job at the factory. Then, the urban shops followed, where rising commercial rent and falling demand made the operation unsustainable. A cobbler in a city might have served a larger customer base, but the rent was proportionally higher. And the urban customer was more likely to adopt new fashions, more likely to view shoes as disposable, more likely to replace rather than repair. By 1985, urban cobblers were serving primarily a niche market. Wealthy customers with expensive shoes, elderly customers with old-fashioned values, and recent immigrants from cultures where repair was still normative. By 2000, fewer than 3,000 independent shoe repair shops remained in the United States, down from 47,000 in 1950. The bench was sold at auction, often for less than the scrap value of the maple. The tools were scattered. The Landis stitcher, which had cost $800 new in 1955, sold for $40 to a hobbyist who would use it twice and then store it in his garage. The ledger was thrown away. No one thought to preserve it. No one recognized it as a historical document recording the economic relationships of a community. But the loss was not just economic. It was structural. Because the cobbler had been more than a tradesman, he had been a node in the information network. He knew who in town was struggling financially because they brought in shoes for repair more frequently, sometimes apologetically, sometimes with a request to defer payment. He knew who was doing well because they bought new shoes and had the old ones resoled anyway, as a hedge, as a way of maintaining quality footwear without the break-in period of new shoes. He knew who had died because the widow brought in the deceased husband's dress shoes and asked if they could be repaired for the son, who was the same size, who was starting his first job and needed professional footwear, but could not afford new shoes on his apprentice wages. The shop was not just a place of commerce, it was a place of information transfer, a place where the status of the community was made visible through the condition of people's shoes and their choices about maintenance versus replacement. When the cobbler closed, that visibility disappeared. The town did not lose a shoe repair shop, it lost a censor. It lost a mechanism for making economic distress visible before it became crisis. It lost a social space where men gathered while waiting for repairs, where conversation happened, where information was exchanged. The contrast is measurable. A Goodyear welted dress shoe manufactured in 1965 had a total lifespan, with proper maintenance, of 20 to 30 years. A polyurethane-soled dress shoe manufactured in 1985 had a lifespan of 18 to 36 months. The old shoe could be resoled 6 times at an average cost of $15 per resole in inflation-adjusted dollars, for a total maintenance cost of $90 over 30 years. Add the original purchase price of $45, and the total cost of ownership was $135 over 30 years. The new shoe cost $40 in 1985 and had to be replaced every 2 years, requiring 15 purchases over the same 30-year period for a total cost of $600. We did not save money. We normalized waste. We normalized the idea that shoes were consumable items with a design service life, not durable goods with indefinite lifespans dependent only on maintenance. The manufacturers, of course, understood this perfectly. They understood that selling one pair of shoes that lasted 30 years was less profitable than selling 15 pairs of shoes that lasted 2 years each. They understood that the shift from repair to replacement represented a 15-fold increase in unit volume. They understood that polyurethane tooling had higher initial costs but lower per-unit costs at scale, and that the investment would pay for itself within 18 months if they could convince consumers to accept the new standard. And convincing consumers was not difficult, because the polyurethane shoe had genuine advantages. It was lighter, it was more comfortable, it required no break-in, it was waterproof. These were not imaginary benefits. These were real improvements in user experience. The deception was not in the claims made, but in the claims not made. No one told you the shoe could not be repaired. No one told you the sole would delaminate after 18 months. No one told you that the cushioning would compress and lose its resilience, that the shoe would become uncomfortable long before it became unwearable, forcing replacement based on comfort rather than durability. The seduction was in the immediate gratification. The leather shoe required break-in. It was stiff for the first 2 weeks. It caused blisters. It had to be shaped to your foot through wear. The polyurethane shoe was comfortable immediately. It felt better on day 1. The fact that it would feel worse on day 500 was not apparent on day 1. And humans, quite rationally, make purchasing decisions based on immediate experience, not projected future experience. The Resole bench was not designed to be efficient by modern standards. It was slow. It required skill. It required a 45-minute process that could not be automated or parallelized. It required the customer to make 2 trips, one to drop off, one to pick up, that could not be collapsed into a single transaction. It required the customer to wait a week, to plan ahead, to anticipate when their shoes would need repair and initiate the process before the shoes became unwearable. But that inefficiency was not a flaw. It was the load-bearing structure of the system. Because you had to return, you had to maintain the relationship. Because you had to maintain the relationship, you had to be reliable. Because you had to be reliable, the community could function on delayed payment and visible reputation. The inefficiency created the friction that made the social system work. Speed is cheap, relationship is expensive. And somewhere around 1978, we decided we could no longer afford relationship. The modern athletic shoe is an engineering marvel. A premium running shoe today contains 15 distinct components, each optimized for a specific function. The upper is engineered mesh, not woven fabric, but a single-piece knit structure with variable density zones that provide support where needed and flexibility where needed, manufactured on computerized knitting machines that can vary the stitch pattern dynamically. The midsole is injection-molded ethylene vinyl acetate foam with embedded air cushion bladders or gel inserts that provide both cushioning and energy return. The outsole is carbon rubber compound with a tread pattern designed through computer modeling to optimize traction on specific surfaces. The shoe contains a carbon fiber shank plate for torsional rigidity. It contains a thermoplastic heel counter for structure. It contains a sock liner with antimicrobial treatment. It weighs 7.2 ounces. It provides motion control for overpronation. It has reflective elements for visibility. It is, by every objective measure except one, superior to any athletic shoe manufactured before 1980. The one exception, it is completely unrepairable. When the midsole compresses, and it will compress because foam has a finite cycle life, typically 300 to 500 miles of running, the shoe is finished. You cannot replace the midsole. You cannot recondition the foam. The shoe is thermally bonded and adhesively sealed in a way that makes disassembly destructive. The upper is knit as a single piece. You cannot separate it from the sole without cutting it apart. The shoe is designed to be worn for 400 miles, then discarded. That is not a flaw in the design. That is the design. The shoe is optimized for performance over its service life, not for longevity. And that optimization is rational if you accept the premise that performance is more valuable than durability. But the premise is new. The premise did not exist in 1955. A shoe in 1955 was not optimized for performance. It was optimized for service life. It was designed to be maintained, to be repaired, to last decades. The modern shoe is designed to be replaced. The replacement cycle is not a consequence of wear. It is the intended design parameter. The old shoe was heavier. The old shoe required break-in. The old shoe offered no arch support, no pronation control, no impact attenuation. But the old shoe could be maintained indefinitely. And because it could be maintained, it created a relationship between the owner and the cobbler that could also be maintained indefinitely. The cobbler knew your name, he knew your shoe size, he knew how you walked because he could read the wear pattern on your soles. He aussi knew if you were gaining weight because the leather stretched. He knew if you were working outdoors because the leather dried out faster. The shoe was not just an object. It was a data stream. And the cobbler was the analyst. We traded the covenant for convenience. We traded the relationship for the receipt. We traded the craftsman who knew our gait for the algorithm that knows our click pattern. We traded the ledger that recorded character for the credit score that records transactions. We traded consequence proximity for anonymous commerce. We traded the bench for the landfill. And we called the severance progress. The bench is gone now. The building that housed the shop is a cell phone store, which will itself close in 4 years when the lease expires, and the landlord converts the space to luxury apartments that will remain 30% vacant because the rent is calibrated to a market that no longer exists in that location. The maple bench was pulled out in 1998 during the renovation. The contractor looked at it and saw 200 pounds of old wood taking up floor space. He sold it to a furniture flipper for $60. The flipper cut it into 3 pieces, sanded off 60 years of patina, stained it dark walnut to hide the stains and depressions, and resold the sections as rustic farmhouse tables for $200 each to young couples furnishing their first apartments with manufactured authenticity. No one will wear a groove into those tables. No one works at a kitchen table long enough to leave a mark. The tables will be used for 4 years until the couple upgrades to a larger apartment and buys new furniture that better matches their evolving aesthetic. The tables will be sold on Craigslist for $80. They will change hands 3 more times over the next decade, losing value each time until eventually they end up in a storage unit when someone moves and cannot fit them in the new space. They will sit in climate-controlled darkness, accumulating monthly rental fees, until finally the storage fees exceed the perceived value, and the unit is abandoned and the contents are auctioned to pay the debt. And someone will buy a mystery lot for $50 and discover 3 pieces of maple that were once a cobbler's bench, and they will not recognize what they are holding. They will see 3 pieces of old wood. They will throw them away. But somewhere, in a small town in the Midwest, in a building that used to be a shoe repair shop and is now an antique store that is itself barely solvent, one of those benches still exists, intact, 2 inches thick, solid maple. The vise still bolted to the corner, the paint still institutional green, though chipped now, showing the bare metal underneath where decades of shoes pressed against it. The surface still bears the shallow depressions where the same tools rested in the same positions for 60 years. The curved knife, the edge trimmer, the burnishing stick. The wood is stained dark in a semicircular arc where the cobbler's forearms rested while he worked, where the oils from his skin penetrated the finish and the maple itself. If you press your hand against that surface, you can almost feel the weight of 10,000 pairs of shoes that were not discarded, but restored. You can almost hear the rhythmic punch of the Landis stitcher, the scrape of the sole trimmer, the quiet conversation between the cobbler and the customer about the weather, about the harvest, about the upcoming election, about the son who just got accepted to college. You can almost smell the leather dust and the neat's foot oil and the rubber cement. You can almost see the ledger, open on the corner of the bench, the entries made in pencil, the careful notation of debts that would be repaid, not because they were legally enforced, but because they were socially visible. You can almost feel the weight of a system that worked perfectly, not because it was efficient, not because it was scalable, not because it maximized shareholder value, but because it aligned individual incentive with community benefit. A system where maintaining your possessions was economically rational. where maintaining your reputation was economically necessary, where the craftsman and the customer needed each other, and that mutual need created a relationship more durable than any contract. We did not lose that system to technological obsolescence. We did not lose it to superior alternatives. We lost it to a polymer that promised convenience and delivered disposability. We lost it to an economic model that prioritized volume over longevity. We lost it to a financial system that replaced visible reputation with anonymous credit scores. We lost it to a culture that forgot the difference between efficiency and value. The bench still exists, the system does not. And in the space where the cobbler once stood, where shoes were judged repairable or irreparable, where character was recorded in pencil, where relationships were maintained through mutual need, in that space now stands nothing permanent. Just a cell phone store that will be gone in 4 years, just a transaction that requires no relationship, no visibility, no consequence, just a swipe, and a box, and a product designed to be discarded the moment it disappoints us. The machine did not fail. We dismantled it, soul by soul, in the name of convenience, and called the silence that followed progress